And welcome to today's lesson. In this first tutorial, we will be able to convert from exponential to logarithmic form and vice versa, and we will be able to evaluate our logarithms. So we are in section 7.4, at least the first half of that, and section 7.5 in our textbooks, and we are looking at a nice introduction into logarithms. So we have an exponential equation, and I'm going to write that as y equals a to the x. An exponential equation is when your variable, our x, is in the exponent. We have a base here of a, and that's being raised to an exponent. Our first objective is to be able to convert out of exponential form and put it into what's called logarithmic form. Logarithms are very useful when we're dealing with exponents. I'm going to put a little double arrow here because it does convert either way. And let's write it into logarithmic form. The first thing I need is my log symbol, and that's just L-O-G. The next thing is I need my base. My base is the thing that's being raised to the exponent. In this case, it's an a. And my base is going to be a little subscript. It's going to be a little bit lower than everything else that I'm about to write. My number goes next, which is y, and then the equal sign, and then this equals x. Now a logarithm, let's see how we write, or excuse me, how we read this, how we would read this statement. We say that the log, put it in quotes, the log or the logarithm base a of y is or is equal to x. That's how you would say this sentence. The log or the logarithm base a of y is equal to x. A logarithm is ultimately representing an exponent. So it makes sense that the logarithmic symbol is equal to the exponent. Because over here in exponential form, the exponent is x. It makes sense that the logarithm is equal to x. Because logs mean exponents. Okay. Now this base is a little bit lower. You see, everything is written in the same line. In fact, I have some little printer paper or whatever you did back in elementary school when you were first printing your letters. The L, the O, the G, and the Y all on the same line. It's the A, it's the base that's just a little bit lower than everything else. In fact, I make it really low down here with the tail of the G. I want to make sure that your symbols are being written correctly. Don't write it like this. Don't put the LOG and then the A and then float that Y up there. I call this kind of a floating in no man's land thing. So please don't do that. We want to make sure that we're using the correct symbols, or at least writing the correct symbol. Okay, so our first objective is to be able to convert from one form to the other. I've got 6 examples to demonstrate that. Let's start here. 5 squared equals 25. Of course, we all know that this is true. I want to convert it out of that form and into the other form. I know that it's in exponential form because I see a base to an exponent and because I don't see a log. So if I want to convert it to the other form, it must be log form. So I have to write log. Next thing I write is the base, and the base is 5. So I put that a little bit lower right there. My number comes next, which is 25, and that is equal to 2. So I know that this is true because, again, this is my exponent. In exponential form, it's easy to see it. It's the superscript, the little number up here. It's a 2. In logarithmic form, it's relatively simple to see it because the logarithm will be equal to the exponent. The base goes here a little bit lower. The exponent goes on the other side of the equal sign. And the only other number that's left is the number, and that goes right there, the 25. So we would read this, the log base 5 of 25 is equal to 2. And we know that that's true because 5 squared is 25. Okay, let's convert the next one. This is 10 cubed equals 1,000. Let's put this into logarithmic form since it's in exponential form right now. We'll write the log. The base is a 10. The number is 1,000, and that is equal to the exponent, and the exponent is 3, so the logarithm is 3. I'm going to come back to this a little bit later in the tutorial, in the other tutorial actually, because this is actually a common logarithm, so we'll talk about what that really will look like in a little bit. But right now we're just converting. Next one, let's convert this out of exponential and into logarithmic, so I need my log. My log symbol. My base is an 8 this time, so I'll put this a little bit lower. Again, right with the tail of the G is a good idea. The number is 1, and that is equal to my exponent, which is 0. I can see my exponent right there. And that makes sense because anything to the 0 power is equal to 1. So 8 to the 0 is 1. One more that's in exponential form, I've got 9 to the 1/2. Remember, 9 to the 1/2, whenever you have a fractional power, a rational exponent, that's ultimately representing a radical. So this must be the square root of 9. And we all know that the square root of 9 is 3, so that's why this sentence is true. But remind yourselves that fraction exponents are coming from radicals. Okay, let's convert out of exponential and into logarithmic. This is log. Our base is a 9 this time. Our number is the 3, and that is equal to my exponent, which is 1/2. Again, notice that everything is all on the same line. Nothing is floating any higher than the other one. If you could just draw a horizontal line through everything, the only number that's lower is the base. It's a little bit lower, just like this guy. Okay, so those are 4 exponential into logarithmic form. Let's say we have a logarithmic equation, and I want to convert it out of that and into exponential. The first thing I like to start off is, what is the base? So I look at this logarithmic form, and I see that the base is 2. It's the subscript. It's a little bit lower, so 2 is my base. What is my exponent? Well, exponents are logarithms, so this logarithm is equal to the exponent, so it looks like my exponent must be a 5. And 2 to the 5th power is 32, which we can check in our logarithmic form. There's my 32. So 2 to the 5th is 32, 2 to the 5th is 32. Sounds good. Let's do one more. Convert it out of logarithmic and into exponential. I need my base first. The base is this 7, so I'll start with that. The exponent must be this -2. And I wanted to show you this one to remind you that a negative exponent is going to make a fraction, because negative exponents mean reciprocals or mean move the base to where the exponent would be positive. So this is going to move to the denominator, and then 7 to the +2 becomes the 49. So I wanted to remind you in a couple things about exponents. Rational exponents mean radicals, and negative exponents mean fractions or reciprocals. Okay, so there's our conversion. That's our first objective. Our second objective is to evaluate these logarithms. So we're going to look at 3 examples of that. When it says to evaluate, we're looking for a value. You almost have the word value in there. And we're talking about evaluating a logarithm. Well, remember that a logarithm, or simply a log, is an exponent. So each one of these logarithmic expressions is representing an exponent. This first one is representing an exponent, the exponent that base 3 would have to be raised to get 27. Now some people can see this in their head already, or maybe they're using their power chart to help them, their power table. 3 raised to some power is going to be equal to 27. Now, if you don't know what that is right off the bat, then maybe just convert it into exponential form. I don't know what the exponent is, so I'll just put a variable. I'll call it big A. So 3 to some exponent has to be equal to 27. And then maybe looking at it in this form, it's a little bit more obvious that it's going to be an exponent of 3, because 27 is 3 cubed. It's one of our special powers. And if 3 to some mysterious power has to be equal to 3 cubed, well, then that exponent has to be 3. So this logarithm is equal to 3. Now let's stick here with example 1 and show a couple more logarithms that would also be equal to 3. We know that the log base 3 of 27 is equal to 3, but what if I change it to base 2? Let's say base 2. What would this number have to be? 2 cubed would be 8. So log base 2 of 8 would be equal to 3. A different logarithm that's still equal to the exponent of 3. I used a different base, so my number has changed. What if I use base 4? 4 would have to be turning into 64 if I'm going to cube it. 4 cubed is 64. How about base 5? If I wanted to cube 5, I'd have to make a 125. So we can come up with infinite logarithms that equal to 3. We just can change whatever we want for the base. And as the base changes, our number, of course, is going to change. It's all about our powers, all about our exponents. So our exponent here is 3, so our answer is 3. Our second example, we have the log base 5 of 1, and we want to know what is this equal to? What does 5 have to be raised to? What exponent do we attach to the 5 to make it turn into a 1? If you're not sure, maybe just convert it to exponential. I'll say 5 to some mysterious, I'll make it a b this time, is equal to 1. And maybe your eyes make more sense from exponential form than they do in logarithmic form, and you see that this has to be 0. 5 to the 0 power, in fact anything to the 0 power, is equal to 1. So this must be the exponent of 0. Looking at our next example, our final example, example 3, I need to evaluate this logarithm. That might have a lot of vocab words that are long or whatever, but this ultimately means find the exponent. Find the exponent that 8 has to be raised to get 1 over 64. Now some people might say, wait a minute, if I have a fraction, we're going to have a negative exponent. And you're right. I'm going to take 8 and raise it to some exponent and say that that has to be equal to 1 over 64. 64 is not just some random number. We know that that is 4 cubed, but that doesn't really help us. 8 squared is helpful. 64 is 8 squared, so 1 over 64 is 1 over 8 squared. And if I wanted to convert this out from the denominator, it would have to make a negative exponent of negative 2. So if 8 to some mysterious power c is equal to 8 to a negative 2, well, that must make sense that c is equal to negative 2. So this exponent is negative 2. We knew that it was negative because we have a fraction here. We knew that it had to be a 2 because we squared to get 64. So put them both together, we've got negative 2. Thanks for watching this tutorial, and we will practice more of this in class. See ya.